right here. All right, so we got tangent squared x plus 4 is equal to secant squared x plus 3. Alright, so before you begin working with identities, it's important to have a strong background in trigonometry. Alright, so what you'll notice is I've got a lot of trigonometric identities here present that you are to use to convert from one trig expression to another one. Some of them, as you can see here, get rather lengthy. Others are rather abbreviated. Okay, so but all of them are equally as important because they allow you to convert from one trig expression to another one, or it just allows you to rewrite. Let's say the sine of a negative angle can be converted to the sine of a positive angle. So all of these identities, some of which I haven't even listed, are very important. All right, so let's take a look at this particular problem where with these identities, what I ask my students to do is only address one side of the equal sign and get that one side equal to the other side. All right, or you could get this side equal to that side, but one of the sides you are not to touch. So the thing I'd like you to notice here is we want to rewrite tangent squared. So what I ask my students to do is know these identities so well, know them so well, that they can go to the identity which would allow them to rewrite tangent squared. And I hope what you can see here is that the identity that allows you to convert to tangent squared would be this one right here. Alright, so what tangent squared is equal to, if you solve for tangent squared here, you get secant squared minus 1. So we're going to rewrite this tangent squared to be secant squared minus 1. Let me rewrite that, secant squared x minus 1. And then we're going to bring down to plus 4. Okay, and again, we're not going to touch that side there. And you end up with secant squared x plus 3, because negative 1 plus 4 is 3. And notice how you get the original problem. So that's all an identity is. It's not solving for any variable. It's just trying to get one side of the equation in your original problem equal to the other side. All right, let's look at another problem. Let's say something like this. All right, so let's say that's the first problem there. Our second problem, let's say we have cosine of pi over 2 minus x over sine of pi over 2 minus x, and they're saying that this is tangent x. Alright, so one of the things that we'll want you to observe here is on the left, this looks rather complicated. But they're saying that all of this simplifies down to tangent x. So in the higher level math classes, what you'll be asked is to do something with this. But what your teacher will expect you is to have an understanding of, hey, wait a minute, maybe this can be simplified down to something. What is another way to write this long-winded, demanding looking problem to something that's much more manageable? And that this idea is to understand this verifying trigonometric identities, being able to understand that this can be simplified down to something much more manageable and making this a much easier problem, doing whatever you need to do to this as opposed to this. All right, so let's take a look at what we can do with this. Again, your your ability to simplify this is all rooted in you understanding your identities here. It turns out that for this particular problem, you'd have all these identities in your head, but the ones that are most useful for this particular problem are right here. You got the cosine of a difference, got the sine of a difference. Here you got the cosine of a difference, got the sine of a difference. You're going to use these identities right in this area right there. All right, so the cosine of pi over 2 minus x is the cosine pi over 2, cosine pi over 2, cosine x, and then if you have a minus, you're going to use this plus sign here. Plus the sine of x, sine of pi over 2, sine of pi over 2, sine of x. All right, so that all expands to become our numerator. And then in our denominator, we have the sine of a difference. Well, the sine of a difference can be written as the sine of x cosine of y. All right, so that's the sine of x, which for us is pi over 2, cosine y, which for us is x. And when you're working with sine, when you're adding in your problem, you should add. Or when you're subtracting in your problem, you should subtract. Well, for us, what we're doing is subtracting. So that's going to remain a subtraction sign. All right, so sine of pi over 2 cosine x, sine of x, cosine x, sine y. So we got cosine pi over 2, cosine pi over 2, which that was x for us, sine of y, sine of y. So for us, y is x, sine of x. All right. So now you're just going to do a little bit of simplifying. Again, one of the things I said initially is that you have to have a strong background in your trigonometry. So you have to have a strong background in what the sine of these angles are. To know what the sine of these angles are, you'd have to have an understanding of the sine curve. You have to have an understanding of the sine curve. This is pi, and this is 2 pi. You'd also have to have an understanding of the cosine curve. All right, this is 1, negative 1, and that's pi, 2 pi. The cosine curve looks more like this. Cosine curves look more like that. All right, so each of these curves will help you simplify this down quite a bit. Cosine of pi over 2, well, that's 0. Cosine of pi over 2 is 0. So you have 0 times cosine x, 0 times cosine x, right there, plus the sine of pi over 2. Well, the sine of pi over 2, you got to go to this curve right here. Sine of pi over 2, that's 1. So you get 1 times the sine of x. You put that there, sine of x. And that takes care of your numerator. Now your denominator is the sine of pi over 2, which we just said was 1. That's 1 times cosine x, minus, bringing that minus sign down, cosine of pi over 2, you got to get that from this curve right here, which is 0. Cosine pi over 2 is 0, times sine x, which is 0. So this is 0. You get sine x. You get 1 times sine x, which is sine x. And 1 times cosine x, that's cosine x in the denominator. And 0 times sine x, that's just 0. And it turns out, notice how we have not touched this side over here. We've only simplified the left side. Another identity that I have not written down, but you would have to know that sine x over cosine x, that does equal tangent x. All right, so this sine x over cosine x is tangent x. The sine of any angle over the cosine of that same angle is a tangent of that initial angle. So notice how we solved another identity. So what have we done? We've taken something that looked complicated and we've simplified it down to something much more manageable, much easier to understand. I'd like to look at another problem. Let's say we have cosine negative theta, cosine negative theta over 1 plus sine negative theta. They're saying that this is equal to secant theta plus tangent theta. All right, so they're saying that these two are equal. You know, this looks a little bit more demanding because you got the negative angles in there. You got the negative angles in there, but all you have to do is do the best that you can to attempt to look at these identities and see which of these identities apply to the problem. Okay? So I'd like you to be able to see you got cosine of a negative angle, sine of a negative angle. It's going to help you to observe that you've got an ability to convert from the sine of a negative angle to the sine of a positive angle. All right? Because all you have are positive angles over here. So you're prompted to use these identities over here. One of the challenges that students have is they don't see how they're going to get to this right away. But still, you have to some degree, you have to just try until you get super comfortable with these identities. All right, so enough talking. Let's attack the problem. Here it says that the cosine of a negative angle is just the cosine of the angle. And I've talked to my students about why this is true. This is not just memorization. It's not just memorization. A lot of these identities, I've shown my students where they come from. All right, so we have the cosine of negative theta is equal to the cosine of theta. So we got cosine theta, and in the denominator we have 1. All right, we got 1. And then the sine of a negative angle, up here, the sine of a negative angle is equal to a negative sine of a positive angle, the opposite of the sine of the positive angle. So we put minus sine theta. Okay? So again, we're not going to touch this side. All right, so right now I'm not sure what we're going to do, but in the past what I've done is, what I've done with problems like this is I've just multiplied it by 1. And that's another challenge that students have with problems like this. Some of this has to do with, you get better at it with practice. All right, so in the past what I've done is I've multiplied this entire expression by 1. So if I multiply this by 1, 1 being, rewriting 1 as 1 plus sine theta, 1 plus sine theta over, in fact, I'll write it in a little bit different way. All right. Oh no, I had it. I wrote it right. 1 plus sine theta over 1 plus sine theta. All right. So I'm multiplying. Anything over itself is just 1. All right. So I'm multiplying my problem by 1. All right. So now what I'm going to do is, as I multiply this by 1, I end up with cosine theta times 1 is cosine theta. Cosine theta times sine theta, let's just write sine theta cosine theta. All right. Then let's multiply the bottom out. Now, as of right now, I do not see how this is going to become this. I'll be honest with you. I don't see it. But what students have to do is get comfortable knowing that they've used a legitimate mathematical technique. There's no mathematical error in multiplying anything by 1. I know that I've distributed cosine properly. You have to feel comfortable knowing that you have not done anything wrong. All right, so though I do not see how this is going to become that, I'm going to keep going. All right, so now let's multiply the denominator out. This is a difference of two squares. You multiply the fronts, you get 1. You multiply the outers, you get sine x. You multiply the inners, you get negative sine x. So the outers and inners negate each other. You cancel each other out, and you multiply the last, you get minus sine squared theta. All right. All right. So now what I tell my students all of the time is you have to be so good with identities, you have to do your homework, you have to practice so that when you see something that can be converted, you recognize it through past experiences. This is very, very, very important. Hey, you have to have done your homework and studied so that when you see something that can be converted, you've worked with identities enough where you say, hey, that looks like this. That looks like this. All right, so I've practiced, I've done enough identities where I know that sine squared plus cosine squared is 1. Sine squared plus cosine squared is 1. So 1 minus sine squared, 1 minus sine squared is cosine squared. So I'm going to replace the 1 minus sine squared with cosine squared. I got cosine theta plus sine theta. Uh-oh, sorry about that. Sine theta, cosine theta, over what I've recognized here as cosine squared theta. Again, I want to really, really hammer this home. If you have not done your homework, you have not studied, there's no way you would say, well, hey, wait a minute, what is 1 minus sine squared? Let me go back to what I've studied in the past. You wouldn't recognize this right away. You would go through some possible long, drawn-out process that may or may not be right, but it just wouldn't be efficient. This is the most efficient way to attack this problem. All right, so now I can see now the direction I'm going to go. Notice how I'm trying to get a sum here. So let's turn this into a sum. So what we have here is we have cosine theta divided by cosine squared theta. That's going to be added to, I'm just distributing the cosine squared here. That's going to be added to sine theta, cosine theta, over cosine squared theta. All right? And now I'm just going to do a little simplifying, and then I'll be done. So now what you have is you have 1 cosine theta over cosine squared theta is 1 over cosine theta, because the cosine thetas would cancel, plus you have sine theta, and then this cosine squared theta would cancel. You end up with sine theta over cosine theta. All right? And what I told you, one of the things that I told you over here is that sine x over cosine x is tangent x. So sine theta, sine of any angle over the cosine of that same angle, is the tangent of that angle. And one thing that I did not write, an identity that I should have had over here, is 1 over cosine x is secant x. All right. So therefore 1 over cosine theta is secant theta. So notice how after a little bit of work you do end up with the same thing. You end up with the same thing. So maybe in your calculus class or something like that, you have to do something with this expression here with all the negative angles, and it would be a source of confusion. What your teacher would expect you to be able to do is say, hey, wait a minute, can I rewrite this in a way that might be more manageable? And you can with your understanding of identities. That's all we have time for.